So let me start with introducing ourselves. So I'm Eyal and I'm part of the solution architect team. Together with me is Mahi, is part of our team as well. You can read about us later on. So what we want to do here is make you understand how to size a Scylla cluster. So in many cases, people come to us, either they already ran into that wall, or they come to us first time from another database, another use case, and they ask for some consulting. So you're thinking about your database, right? So the first thing most people come in, I have 20 terabytes of data. That's great. I know exactly how much disk you need, but what does the cluster look like? It's a completely different paradigm. Sometimes it's a storage play. In many cases, what we find time after time, that it's actually a workload play. So you have to think those two items, and we'll talk about each one of them. So the first thing that you have to ask yourself is, what's the business need? So I know I'm starting very, very high, but it's extremely crucial, because you're tasked by your business team to store 20 terabytes of data. But why? What are you trying to get with those? For example, how many users you're going to be serving from those business units? What is the growth projection that you have in that use case? The application, okay? For example, what does this application does? Okay? What is the needed from infrastructure perspective or from data throughput that you need from that system? You don't know those. And you have to ask those questions to get that information from your people. One crucial thing that most people do not ask, what is the latency budget I have? Do I have 100 milliseconds? Do I have 200 seconds to answer the query? What does the query size look like? What is the read-write ratio that I have to apply for my system? And for example, do I have to answer queries on different geographical locations? So again, thinking about those application features also will make or break your cluster. Infrastructure. Most people come with an infrastructure in mind. I have an on-prem. Great, how does that look like? In early days, people say, I want to repurpose my cluster. And when we heard repurposing my cluster, all lights went off. And the reason for that is, in most cases, this is like a 2,000-year-old circa hard disk with a Pentium MMX. That's not going to work. So you have to think about your infrastructure. Today, we're talking about cloud vendors. So you have Packet, you have AWS, Google. Your hybrid solution, maybe you're doing on-prem and others, or multi-cloud. It has an impact on the sizing of the cluster. What is your resiliency play? For example, what are the backup strategies you're going to deploy? What is the node recovery time that you have between losing a node, bringing a node? Okay? For example, some people say, I'm not going to, it's going to take me a week to bring a new node because I have to purchase it from Dell. Okay? Then there's implication for that one as well. Data center. If I lose a complete data center, then what happens to myself? And for sure, data security. The most important thing is, from our perspective, is developer and operator friendliness. What does the QA system look like? Yes, you might test it on your laptop. It's never going to look like the same on your clusters, because the workload is going to be completely different. The infrastructure is going to be completely different. How easy is to migrate from QA to staging to production? All those items have to come into consideration when you are building your own data center. So let's start from the obvious. Okay? So we start from storage. In many cases, people will tell us, hey, I have this storage need. Why? So you have to ask yourself, for example, am I building, for example, a user profile? Am I building some IoT solution? How many records per items will I have? For example, how many records for each one of my profiles? How many records for each sensor will I store? That information, again, is crucial to build the right solution. What is your data attrition policy? Do you TTL data? People say, I will never delete data. In many cases, they do, because they have a TTL of 1 year that also have an implication on the storage system. What is your text format? Scylla, by default, will compress data. However, if you're going to bring me blobs or binary, probably it's going to be hard to compress them. Text files, much, much easier. So again, impact on storage. What is your requirement on replication factor? As you heard today, some people say, I'm good with replication factor 1. Others will say, I need 7. Again, impact on storage. And it comes also back from the business side. And what does your storage system look like? I want to use OpenStack. I want to use VMware. I want to use all my own bare metal. Or I want to use EBS volumes from AWS. Each one of them will have an impact on your solution. The shape of your workload. And I would argue this is where most people will stumble upon the first stone. So we want to understand throughput versus latency. In most systems, that's what we ask. What is your latency budget? Well, people say, hey, I want to store 20 to get data in return within 20 milliseconds. Great, what's your throughput? Let's say 100,000 requests per second. So we can build a system based on 100,000 transactions per second and 20 milliseconds. But what would happen if you push in, let's say, 110,000 because you had a small peak? That can throw you off completely as a hockey stick on the latency mark. So the 99, 90 percentile that you're expecting to be at 20 milliseconds will end up at 3 seconds. Okay? Again, that sizing and understanding help us a lot to understand exactly what you're trying to get from. Shape of workload, you have probably already heard about our workload prioritization. And this is exactly where it comes to play. So we know, for example, that your OLAP is kind of those big trucks running on the highway, but they're a little bit slower. So you might want to put them on a different capabilities. Same thing with transactional. We want to understand the workload. And you will see down this presentation how we do that on a daily basis with our prospects. Data model. Go back to your developers. So secondary indexes or materialized views. Every time you change your base table, it actually creates additional 2 mutation of data in the replica or in the view. So you thought you're going to have 10,000 transactions per second, but actually you have 30,000 transactions per second just because you did 1. Okay? So all those items have to come into play when we actually size a cluster. Another impact, for example, we know, for example, that materialized views and secondary index cause an increase in CPU and I/O. And the other one is the partition size or the workload per partition that you send into the data. It has a lot of impact on throughput and about CPU ability to process this information. For example, partition key definition. If you use, I don't know, gender as your partition key, probably a bad idea because you're going to have 49% of the population in one, 49% on the other ones, and 2% of those who do not want to declare their gender. Okay? So it's going to change the way data is stored. However, you're going to use social security number. That's a unique partition key. So there's only one person with that one as long as you have not been hacked. The impact of auxiliary system. Are you using Spark, Presto, Kairos, Kafka to connect to Scylla? So think about, for example, you have some kind of an analytic ad hoc Spark connector that you're using. But you don't think that that data scientist will run his Scylla code exactly at 9 a.m. on Monday morning when you expect the highest throughput. That means they have this huge spike. Nobody understands why the latency came in. Let's talk about the machine that you're using. So the first thing you have here is your CPUs. Somebody has to do the work. We look at CPUs as a distributed system. Each one of those cores is a dedicated portion that we shard the information into. So we will shard every piece of your data into a specific thread. That computation has a lot of impact on our ability to process data, computation process. We size roughly 10,000 transactions per second on a physical CPU. That's the kind of a rule of thumb that we take into account. Not always the case, but in most cases it works. This is how we do our sizing. The next thing we look at is memory and data volume. Okay? We like to have a reasonable ratio between your RAM and your disk space. In some cases, we'll ask you not to cross the 50-to-1 ratio. So every gigabyte of RAM will allow you to store 50 gigabytes of data. There are, however, for example, i3-en systems, that ratio goes up to 1 to 80, which is fine. But we do want to understand, because that has impact, as you've seen on the presentation this morning, about our ability to store caching information, because then our caching ability is a little bit more limited. Storage. Please, your modern systems can have SSDs or NVMEs that are prices going down. It doesn't make sense to have spindle disk anymore. As Glauber said in the morning, please do not use, we don't recommend using spindles. We know there are users who do that. However, it doesn't make sense in these modern systems. Connectivity. That's the last part everybody thinks about. And typically, that's the first part that hits us. You connect your servers, you told us everything, fire up, and you see everything running at 125 megabytes per second. That is your 1 gigabit network. Everything gets stuck. We ask you, hey, where's the monitoring? You open the monitoring. We see everything is not moving. Replications behind, compactions behind, everything is behind. Why? You connected a 1 gigabit network. There is no reason to do that. Today, cloud vendors offer on the minimum 10 gigabit per second. There are 25, 50, and 100 gigabit per second instances, both on AWS, on Google, and as well as on Azure. So again, think about your network as one of the parts of the system that you have. By the way, if you're using the smaller instances, for example, on AWS, they have a variant network, in most cases, beyond the i3, below the i3 8X or the 8XLs, you're going to get a fraction of the network. It means that 1 to 2 gigabit per second. Again, to the connectivity, please also enable client to server. Most people say, hey, my client is sending 30 megabytes per second. Not a problem. But there's something you have to think about beyond that. What happens if a node fails? We have to rebuild it. Again, we will use that network. Geo-replication benefit, as you know, Scylla enables you to do replication without any problem over different geographic replications. However, we have seen cases when people try to rebuild a data center from east to west. That's going to be costly, and that's going to take time. You have to take that into consideration as well. So let's build a system, and for that, I'm going to order and ask Mahi to join me. And I'll take notes.
All right. So let's see how this works.
You just click on this one.
All right. So let's say, I'm going to be, I want to build a backend for my application. I am, retail system. We have user profiles in our system. We handle about 30 million user profiles. The number of records we have in each of these would be like maybe 12 record, and like each the average size of each row would be around like maybe 3 kilobytes for what we're looking. Most of these are data types of text, and let's say like we have we are very latency sensitive, and we want to be able to have latencies around like 12 milliseconds or maybe 10 milliseconds for read, and 15 milliseconds maybe a little bit more relaxed for writes. So and typically our peaks are somewhere around 130,000 to 150,000 is our somewhere around that, and our read to write ratios are somewhere around 7:3, and we also have a lot of requirements around cloud, using cloud infrastructure, and having a cross-region sort of requirements. And we also have a lot of data scientists who want to work on this data. So there's some Spark workloads also which we use sometimes for doing this, and we want to be able to have the necessary infrastructure for handling all of this. And we want to make sure there's resiliency, so it should be RF3 and also have multi-regions present for the cluster for DR. Can we go ahead and build a system, Eyal?
We can. So this is exactly the information I'm going to ask you. So when you try and build with us a system, that's the information you have to provide us. And this is how we can make it the most efficient from your perspective. The worst thing that can happen for you is you under-provision, because then you come back to us, hey, this stuff, it doesn't work for us. The worst part from your job perspective is going to happen. You're going to oversize it, and your director comes back and say, hey, that's cost me too much. So what I'm saying is talk to us on the sizing, and we'll walk through this sizing exercise and see what's the outcome. So let's go for the next slide.
That's great. We would definitely want to have like a TCO on this, and we want to see if it makes sense for us to do it or not.
Sounds good. So let's build the system. This is the summary. So we did some back-of-the-envelope mathematical understanding, and we understand that the raw data, after multiplying the number of users by the rows, by the payloads, we're talking about 2 terabytes. Okay? And we have roughly 1 terabyte at the beginning because the system grows. So you have to think about your growth progress, right? What's your expectation for the next year? And we have all this information about the typical row size, data model information, latencies information, read-write ratio, and replication factor. And let's go for it. I just want to remind you one more thing. What I said, like 10,000 operations per second per physical CPU. We will use size-tier compaction strategy. Remember the talks from this morning? Yep. So we need 2x on the storage to store enough to be able to do compactions. We know that there is a read-heavy load here, so we want to have enough RAM to support the workload. And
it's write-heavy. It's 7:3.
Okay.
70:30.
7:30. Okay.
Yeah.
And we also know that would you use any materialized views or secondary indexes?
To begin with, not, but we will slowly add materialized views.
So we have to think about that one in the future as well. So let's see how this system looks on Amazon. So in this system, what we'll size is 3 i3 4x large. So we'll have roughly 12 terabytes of data. Okay? Because we needed initially 2 terabytes, remember? Multiply it by 3 for the replication factor, it's 6. And its size-tier compaction strategy becomes to 12. So this is roughly the storage size that I needed. I'm going to be using NVMe. So at this point, I'm less concerned about the latency requirements. They're actually pretty relaxed for an NVMe system. And we need 30 threads. 30 threads means that I need 15 physical CPUs. Remember, we had 150,000 transactions per second requirement. So with 15 physical CPU, that translates to i3 4x larges.
In addition to this, do we also need any nodes for monitoring and manager and things like that too?
Excellent. So yes, we need one additional node. We need one additional node roughly at the same ballpark as our actual nodes for monitoring and manager. So we'll have another i3 2x large for Scylla monitoring and manager. It's going to give us another almost 1.9 terabyte of storage for that. And for the Spark, I'm guessing right now, really, you'll need 3 i3 2x larges for the Scylla Spark, for the Spark machines. That's the system. So if you do that sizing exercise with us, what we'll find out that every time you give us the information, we'll send you back a sheet that says exactly that. How many nodes you need, how many cores, why we think that. And you can start negotiating with us about the actual use cases. So let's now make it a little bit more efficient. Let's say I want to use i3 EN systems. Okay? From the i3 EN system perspective, we're going to have the same CPUs because i3 and 3x larges have the same amount of cores as with the i3 XLs, i3 4XLs, but we'll have double the disk space. So if you know, for example, that you will be storing more data, but the actual workload will stay the same, that would be my recommendation for you to go with it.
Would always adding more disk be beneficial? Is there any trade-offs that I have to think of?
You just have to think about the trade-off between memory and disk space. Because if you want to make sure that your memory is efficient enough in terms of storing the caching layer part of Scylla, you want to make sure that you have enough memory for each one of those gigabytes you store there. So we know we might ask for AWS, but we'd say, OK, let's see how it looks on other cloud vendors in the system. So let's see how Azure looks like. So Azure has a system that looks the same. It's called the L16v2 platform. It has the same NVMe capabilities, same CPU capabilities as the AWS ones. So if you look at this implementation, it looks the same as AWS, just the names are changed.
What is so special about these instances?
So they are available today from Azure, East and West. They have NVMe, which is the same sizes as you would have on i3 systems on AWS. So it's an identical system. We have users who want to use same sizes. So I would recommend multi-cloud. Go Azure and AWS. It's going to give you the same deployment scenarios on both systems without changing anything on the Scylla side.
And is NVMe disks only preferred to be,
Our preference is NVMe, and the reason for that is if you look on both any EBS or persistent storage that Azure brings into the play, in the EBS volumes, you are limited to 10K IOPS. That's the maximum a persistent disk can do, and you can get that only if you cross the 3.4 terabyte per volume, which can be challenging. With Azure, it can be even more challenging. Those have 5K IOPS only. So let's see, for example, how it looks on Google Cloud. Google Cloud is a little bit different in that regard. The difference here is the NVMe. The NVMe and Google you can have up to 8 NVMEs. However, you can have only 375 gigabyte each one of them, which limits you to a 3 terabyte per node. This is why here you have double the number of nodes, so you kind of a little bit over provision on the CPU side because of the deficiency on the NVMe sizes. And last, but the most important from our perspective, you don't want to manage this. You don't want to do anything. You just want somebody make sure that take care of Scylla for you. You have the same idea with Scylla Cloud. We will size it for you. We'll tell you exactly how many nodes you're going to have to use. And if you see here, yes, it is based on AWS, and you can deploy your system with Scylla Cloud.
So when you say you have a fully managed instance, and we know we use cloud in generally within our company, but if you are going to manage it for us, what do we need to know about it?
Great. So you will get from us all the monitoring data, so you know exactly how much transaction you're using, what is your workload looks like. Everything is going to be given to you. However, everything about repair process, backup and restore, anything that, let's say, a node fails, we will take care of it, and that gives you a peace of mind, and you just make sure that you write your application.
So all we need to know is SLA requirements for this?
Only SLA requirements from our perspective.
OK.
In the more rare cases, when you actually build it on premise, it means that you will have to build the system yourself. There are Dell, HP, and other servers out in the market. Talk to us, explain to us what you're trying to build. Again, 10 gigabit network is extremely common today, so don't go cheap on that one. That's what I would ask you to consult with us. That's our sizing process. If you can go 2 slides forward. And this role play we did here, it's actually documented. So if you go on ScyllaDB.com/sizing, you will see a questionnaire. You fill in this questionnaire, and again, you'll get back, from our perspective, how you should build the system. A full architecture document. It's not that big, just going to tell you how to use it. Okay? We need this information, so don't tell us we need a cluster. I know that you need a cluster, me too. However, I need a little bit more information to do that. So again, I ask you to interact with us. It's going to give you a lot of benefits to understand how properly size your cluster. And to summarize, don't think only storage, please. Okay, that's the first common thing that we see. Gather the information from all your stakeholders. Throughput for SLAs, growth expectations, what is the security and compliance you need. Select the right infrastructure. Talk to us. Please talk to us. We want to understand how you build it. At that point, we can actually help you make sure the deployment is easier to be done.